So one more thing to add into the question that we last did on the limiting reactant calculation, and then just go ahead and put our coefficients in here. So, whoopsie daisy. So we had 6 moles of potassium nitrate to every 2 moles of aluminum nitrate to every 3 moles of potassium sulfate. So there we go. So same exact numbers as what we had on the last calculation where we were calculating limiting reactant of 4.68 reacting grams of aluminum sulfate reacting with 5.65, where we calculated out that the limiting reactant was in fact the potassium nitrate and that it's going to produce 3.97 grams, or that actually it should produce 3.97 grams. That's the theoretical yield. So when you are calculating these things and you are doing stoichiometry, what you are calculating is the theoretical yield. Well, what you actually get in a lab is the actual yield. So let's say we do this experiment and we only got 2.65 grams. So this is what we actually got in the lab, so it's called the actual yield. Very creatively named, I know. So the percent yield is going to be equal to the actual yield divided by the theoretical yield, and then take this whole thing and multiply it by 100. So we're going to plug in the actual yield from the question of 2.65 grams. So 2.65 grams of aluminum nitrate. And then the theoretical yield is what we calculated back up here in the original limiting reactant question. So this 3.97 grams is our theoretical yield that we're going to put right down here on the bottom. 3.97 grams of AlNO3. And then we take this whole thing and we multiply it by 100. Now if you notice, the units on this are actually going to cancel out. So the grams of aluminum nitrate cancel out. So the only units we have on this is the percentage coming from the multiplying by 100. So when you plug this into your nifty little calculator, you get 66 point blah blah blah. 66.7506 blah 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 blah. Well, we're only allowed 3 sig figs, so 66.75 rounds to 66.8%. And there you have it.